Hey guys, today we're talking about object states and how these can be used in our games. Now, conceptually, states are quite simple. We use them all the time to define our own state of mind, such as being awake, asleep, happy, or sad. And we know that there are different properties and behaviors associated with these different states. You can move around when you're awake, but not really when you're asleep. So there are things you can and can't do in different states. So in our games, we can create our own states for objects and have them behave differently depending on what state they're in. And this is really useful not just for organizing your project, but for creating more complicated and contextual behaviors, which you might describe as artificial intelligence. Now, you may have also heard the term a state machine or a finite state machine, and that just refers to the whole system that manages the states. So by saying machine, we mean the system is relatively complex and self-sufficient. So the object is capable of acting different in different contexts, and we might even say it's like a little automaton with a primitive intelligence. All you have to do is switch it on, and the rest will just happen like clockwork, as if it were making its own decisions. Now, a really great way to illustrate how states work is with a flowchart. So we're going to draw one up here and take some classic examples of enemy states as our point of study. So let's make an enemy type, and we'll give it 4 possible states that it can be in. So we'll give it an idle state, a wander state, an alert state, and an attack state. So in the idle state, we'll just say that its behavior is to stand still and do nothing. And in the wander state, we'll make it move in a random direction. In a lot of games, this might be the patrol state as well. Next, in the alert state, we'll say its behavior will be to chase the player. And finally, in its attack state, we'll have it take a swing at the player. So far, we've described the enemy states and the behavior we want it to perform in each state, but we haven't said how they relate together, how it's going to change from one state to the other. And we can call these conditions or triggers to change to another state. So our states have to not only contain instructions for what the object should do, but also have it check for these triggers or conditions to move to another state. So for example, while we're in the idle state, we could set up a detection radius and say that if we detect the player within that radius, we'll switch to the alert state. And when we're in the alert state, we could have another smaller detection radius for attacking the player. That way we're able to switch states in this sort of direction. Now we're getting somewhere, but we need to add a way to get back to previous states. At the moment, if we end up attacking, we're just going to stay in that state forever. So we have to complete the loops here. So we could say once the attack animation is finished, we'll return to the alert state just automatically, ready for another attack if we detect the player still in our little radius. And when we're alert, we'll say that we'll return to the idle state if the player goes outside of our larger detection radius. And finally, we have our wander state, where we just move around randomly. And there's a lot of ways that you could do this, but let's just say that after about 3 seconds in either the idle or the wander state, we'll have a 50% chance of moving to the other state. We'll also want to add the same detection radius to our wandering state so that we can transition to the alert state here too. Alright, so this is looking pretty good now. We can see how all of the states are related and how we could actually go about coding this. So the basic code logic for a state is just going to be, if we're in this state, do that state's behavior. And there's a few ways we can accomplish this using GML in GameMaker. So in our project, we can have a variable called state and be checking what it is equal to determine our behavior. So every step, we can use if statements to check what the state variable is currently equal to and then wrap all of the state-dependent code in those conditions. And alternatively, you can just use a switch statement here to accomplish the exact same thing. Those 2 bits of code are essentially equivalent, it just gives you a different way to set this out. But back to the if statements, and I just want to point something out. So before I said we'd be checking what state is equal to, but what exactly are we checking for? At the moment, I'm just using words here, but this isn't proper code. So we could use strings for the possible states, right? I could be checking if state is equal to the idle string, and that's totally fine. That's a viable way of doing it. It makes it quite readable. But another way you might come across is to just use numbers. And the reason you might want to use numbers instead of strings is just that it takes up a lot less memory. But of course, this is going to make our code a lot less readable. You would have to keep an index somewhere to remind you what number denotes what state. But there is another alternative, which is my personal favorite for this kind of thing. So we can use what's called an enumerator or an enum. And think of an enumerator as a way to create our own kind of data type. And this is how it works. So if we're going to declare an enumerator, we begin like this. We say enum and then whatever we're going to call the enumerator, states. And basically what we're going to do is outline all of the possible states we can be in. So idle, wander, alert, and attack. So now, the way enumerators work is we can manually give them a value, like on the right, or we can just comma them on the left. And those two are actually going to be equivalent. Because if you don't specify what the value is and you just comma them, it's going to automatically assign them numbers in chronological order, starting from 0. If we wanted, of course, we could make them equal to 2, 7, 1,000, 1,000,000. And it doesn't really matter in this context, but we might as well just keep it simple and use chronological numbers. So now to actually refer to one of the states in this enumerator, we would write states dot and then whatever state. And now remember, so states dot idle, that is equal to 0. It's as if you had just written 0 there. And states dot wander, that would equal 1. It's also worth mentioning that enumerators are global in scope, which means they can be accessed from any object. So you can just declare these once, say in a controller object, and all objects can use the same indexing system here. So you can outline all of the possible states. It's a great way to keep things simple and centralized. And another great thing about using enumerators instead of numbers or strings is that now, since we've kind of set up our own data type, it's going to come up in the autocomplete. So we don't have to remember if we called our state alert or chase or whatever, we can just write states dot and an autocomplete list will come up for us. So it's sort of a compromise between using the strings and the numbers, but it makes it a lot more readable for us. And another great thing about enumerators and setting up an indexing system is that you can use it for so many things now. So for example, we could set up a sprite array that stores the appropriate sprite for each of our states. So for example, if I have an idle sprite for standing still and then a moving sprite for my wandering and alert, and another one for attacking, so I could store those in a sprites array. But actually, instead of just using the numbers here, I could use the enumerator. Because remember, all of those are equivalent to those numbers. But it makes it really clear what that sprite is for. And now in my code, when I'm changing the sprite index to be the appropriate sprite, depending what state is equal to, I can access the appropriate sprite from my sprites array. So at any point in time, state will be equal to states.idle or states.wander or alert or attack. And you could do exactly the same thing for something like state-dependent dialog. So we could use arrays within arrays or a combination of data structures for this. But as an example, so we could have a dialog array just like before, and then that array itself would be storing another array with the available dialog for that state. So for example, for the alert, we just say hey or stop. And then for the idle state, we have a couple other dialog options. And when it comes time to actually say something, we could, for example, just choose randomly from the array at that state indexed in the list. But this is getting a little bit more advanced. Don't worry if you have no idea what any of that array stuff does. It's not really the point of this tutorial. I just wanted to illustrate some examples of what you could do. Anyway, let's come back to our enemy states example. So we're going to jump into GameMaker now, if you haven't already, and set up the state system using the enumerators that I described. So here is my project, and I just have an object called obj enemy type right here. And I'm not going to go through everything in this project because this video is more about concepts than anything, but I'll explain everything as we go. So in your create event, you should have this set up currently. So this is for declaring our enumerator, and really this should be in a controller object because presumably you're going to have multiple enemies in your game and you don't want them all declaring this enumerator. You only have to do it once. But I'm just going to keep it here for simplicity. I'm only going to have one enemy type object running around. And of course, you also need the state variable, and I've just set it to start off in the idle state. Now, coming into the step event, so I've set this up exactly how we discussed it previously. I have a bunch of if and else if statements, and I'm checking if our state variable is equal to all of our states here. And again, just a reminder that you could also use a switch statement. And in here, I have already set up all of my behavior code, just using the handy region. So if you didn't know about this, you can just write hash region here and then an end region somewhere below, and it will allow you to wrap and unwrap that entire region of code so you can hide it. So I'm just going to briefly describe this code for the behavior I outlined before. You can skip ahead if you just wanted to watch this for the conceptual stuff. I'll leave a timestamp in the comments. But this is just if you wanted to know how I've gone about setting up this behavior. So for our idle behavior, and I've broken this up into 3 kind of sections so that we have the actual behavior, the triggers to move to different transitions, and down the bottom I'm just also setting the sprite. So for our idle, because we're standing still, we're not really doing anything. All I'm doing is I have a variable that I actually declared in the create event here, starting at 0. And this is what we're using to keep track of how long we have been in this state. So remember how I said every 3 seconds, I'm going to do a 50% sort of random coin toss to see if I should change to the wandering state. The way I've set this up is counter is going to be incrementing every second, which means every frame, which means it will be incrementing 60 times every second because my room speed is set to 60, there's 60 frames in this game. So every second it's going to go up by 60. So we're going to check if our counter is larger than our room speed, which is 60 times 3, that is going to be 3 seconds. So this variable here is going to be assigned the value of 0 or 1 randomly, and we just check here using a switch statement. In the case that it's equal to 0, I'm going to change the state to the wander state. And in the case that it's 1, that means we kind of failed the coin toss and we're going to stay in the idle state. The only thing I do here is I reset the counter to 0. So we'll basically go back to here and wait another 3 seconds and do this all again. And the reason I've left off the break here is because I also want to be resetting the counter if I'm changing to the wandering state. Okay, so that would be the transition to the wander state, but we also have another one, which is our detection radius. So I'm just using the function collision circle here. I've set the radius to 64. And of course, we're checking for whether the player is within our radius. If it does find it there, then we change our state to the alert state. And finally, of course, I'm changing the sprite index to the enemy's idle. So that's the idle behavior. And for the wandering, similar to the idle, I have the same kind of counter system here set up and the random coin toss flip. But because we're wandering, we're also going to be changing our X and Y position, right? We're moving around the room. And the amount that we're moving is just going to be equal to this variable. And what I've done is I've kind of set these up to be a random direction. So in here, for my movement code, these are the relevant variables. So I have a speed of just 0.5, that's how fast the enemy is going to move. And what I'm having it do is just choosing a random direction to move. So this function here is going to get a random integer between 0 and 359, so it can move in any direction. But the problem is there isn't really a way to tell GameMaker to move in a direction. It can only really talk in terms of horizontal and vertical movement. So I have to translate my kind of vector here to horizontal and vertical movement. And we can use these functions here, these length_dir and length_y functions, to get the horizontal and the vertical components of that vector. All we have to do is give it a length and a direction. And of course, the length is just going to be how far we can move in each step. And that is just going to be our speed variable. So in addition to setting it that one time in the create event, I'm also kind of re-rolling that directional change. If I'm staying in the wandering state, I also am going to just randomly change my direction again. And then every step, it applies that horizontal and vertical movement to the X and Y. And just like the idle, I also have the same detection radius set up here to change to the alert state. And down in the sprite, I'm setting it to the walking sprite, which I called SPR enemy. And I'm also just setting the image X scale to be relative to our movement. So basically, if I'm moving to the left, if the sign of move X is negative, because that's what sign does, it makes it either -1 or 1. So if my move X is any negative number, this is going to be equal to -1, and we will be looking to the left because my sprite defaults to looking to the right. And if it is a positive number, we're moving to the right and I want to be looking right. So the image X scale will be 1. Okay, that's it for our wandering. So moving on to the alert state. So our behavior here is to chase the player. So this is quite similar to the wandering state, only instead of just choosing a random direction, we're going to choose a very specific direction. It's going to be heading towards the player, and we can get the direction between 2 points, which is going to be wherever our enemy is and wherever our player is, using the function point direction. And again, because our movement is confined by our speed, we can't move any more than our speed variable in a step. We're going to get the vector that has a length of speed in the direction of our player. And then we just apply that movement every step. So for our transition triggers, remember the alert stage had 2 kind of detection radiuses. So not only are we checking to see if the player is still within our alert radius, our large alert radius, because if it hops back out of our alert radius, we're just going to return to idle. So if it doesn't detect the player here, we return to idle. We also have a smaller detection radius for attacking. So if our player is very close to us, we're going to change our state to the attack and actually take a swing at the player. So finally, in the sprite, I'm doing the same thing as with the wandering. I'm setting the sprite index to moving, and I am setting the direction of our sprite with the image X scale. Okay, and finally for the attack. And now I don't want to go too much into this one because it's going to be extremely dependent on how your attacks work and also the sprites that you're using. For me, what I have is kind of an attack object called obj/. And basically, whenever I'm attacking, I'm going to be creating that object. And that object has its own code for detecting whether it hits another object. And basically, if it sees that that object is not its creator, it will do damage to that object. And that's why I'm sending things like the creator over to the / object. That's just so it can know who its creator is, so it won't harm them. I'm also sending over our image X scale here, so that the / will be facing the same direction that we are. And you'll probably note that this entire thing has been wrapped in a condition if my / is equal to no one. And basically in the create event, again, I have set up this variable called my /. By default, it is equal to no one. Because basically I don't want to be creating like 600 / objects while I'm in the attack state, because remember, this code is running every single step of the game. So I don't want to keep creating / attacking objects. I only want to do it once. So basically I say if my / is equal to no one, then I go ahead, I create the / object. I set its ID equal to my / because this function returns the ID of what it's creating. I go ahead and do all this initialization. I set the image index of ourselves to 0, so we're at the start of the attack animation, and it will only do that once for this attack phase. I've also set up the / object to destroy itself once it's finished its attack, and it will reset that variable for us. So down in the transition triggers, so remember for our attacking, what we're doing is just as soon as we hit the end of our attack animation, we're going to just go right back into our alert state, which is what this says. So if our image index, which is the current frame that we're on, is larger than our image number, and then -1 because our image index starts from 0. So if, for example, we had 7 frames, the 6th frame would be the last one. So I have to put -1 here. So if it reaches the end, then we go back to the alert state. And of course, down the bottom, I'm just setting the sprite index to be the /. All right, so that's it for the behavior. So now if I run the game, this is how it's going to look. So here is our enemy right there. So you can see that it's in its idle right now, and it just changed to the wandering sprite and chose a random direction. And you can see if we get close to it, it starts chasing us like that. I set up something so we can just visualize its radiuses. So there we go. That is its alert radius. If we go inside it, it starts chasing us. And then if we hit its attack radius, it attacks us. All right, now lastly, I want to show you another way of setting all of this up that can add another layer of organization to the project. So instead of putting all of our code in this one code block here and using these if checks or a switch statement to decide which code to run, we can actually just put these all in separate scripts. So let's just pull all of these out and put them into scripts. So let's grab all of the behavior code and cut it out, and we're going to create a new folder in scripts. We'll call this states. And I'll add another subfolder for the enemy. And finally, we'll create a script, and this one is going to be called enemy state idle. Let me just grab that. And just paste it in there like that. And we'll do the same for all of the other states. All right, there we go. And we could actually just replace all of our code right now with just calling the script like that. And that would be equivalent to what we had before. But that's not really why I wanted to show you this. So now that we have all of them in scripts, it would be good to just run the one script that state is set to. So I am going to come into the create event. We're going to set up a states array. And each place in this array is going to be indexed using our enumerator system. And each place is basically, it's going to store the script that we want to run for that state. So for the idle state, I'm going to be storing that enemy idle script. And we can use this Same system in all of our objects, only we're going to be setting them to different states if we want them to behave differently. So let's go ahead and fill all of this in. And now remember, our state variable is going to be changing its value from states.idle to states.wander to alert and attack. And remember, these are equal to 0, 1, 2, and 3. So we can use the state variable to access the appropriate script in our array. So if I say state here, it's going to be accessing this script. So now, instead of doing any checks, all I have to do is say run the script, and then one of the scripts in our states array. And just like that, it's going to access the appropriate entry for whatever state that we're in. So there we go, everything should work exactly the same as before. All we've done is sort of change how the project is organized. And on that point, if you're watching this and wondering, well, if it all works the same, does it really matter how I'm doing it? Or maybe you got a little lost as we were going through and think it was easier back when we just had it set up with the if statements and strings. And if that's what you're thinking, that's totally fine. Use the strings, it will work exactly the same. A lot of this is just going to come down to preference, organization, and experience. The reason the enumerators are really cool, for example, and using them as an index in multiple places, like with our scripts array or with the dialog as I was discussing before, is that it generalizes the system. If we change something later, you only have to change it in one spot. And obviously there are many more ways you can take this further. You could add a parent system for multiple enemy types, generalize the sprite changes into variables so that each enemy can have its own sprites, have different idle and wandering states for different enemies, and also just transfer any repeated code into scripts, like a collision check, for example, so that you're not repeating code. You can also use states and state machines outside of AI and your interactable objects for things like game states, pausing, menus, and so on. So I hope that gives you an idea of what states can do and why they can be so helpful. But that about wraps things up for today's tutorial. So today's topic on object states was actually chosen by a vote on Patreon, so I'd like to thank all of my patrons who voted and who are supporting me to make these tutorials. Also, a special shout out to 3D Monkey Biz, Danielle Hargrave, Max Molinaro, and Uthelian for their support. I hope you guys are well, and I'll see you next time.